Hello, this is Mr. Powlin, and I'm going to review with you here some stuff that we've been doing in Unit 2 of Algebra 1. We've been studying linear functions, and we've learned how to represent those linear functions with an equation, a table, and a graph. The linear equation of the linear function we're going to look at here is y equals 2x minus 4. And as I type in that linear function, you can see the graph of it pops up here. I have a graphing calculator application, and let's check and make sure this is the correct graph of our equation, knowing from slope-intercept form that the coefficient in front of x, the 2, that gives us our slope, right, from y equals mx plus b form. Let's check and see if the slope is 2. So let's see if I start here. If I go up 2 units, then I have to go over 1. So the rise over run is 2 over 1, and it's got that constant rate of increase that you find with all linear functions. So the slope is 2. The y-intercept should be negative 4. The y-intercept, remember, that's the point where x equals 0. So if you put 0 into the equation, y will be negative 4. And right down here, yes, the y-intercept is 0, negative 4. Now what we can do is we can take these points and we could put the points in our table. Our table, first point here would be 0, negative 4. And I could go up along the graph and I can get some more points. So let's see, let's go across to x equals 1. When x equals 1, y equals negative 2. So there's another point for our table. Let's go up here, x equals 2, y equals 0. And hopefully you're noticing by now that constant rate of increase we always see with linear functions. X is increasing by 1, y is increasing by 2, so that the pattern continues. Our next point should be 3, 2. And yes, good. The point did show up on our graph at 3, 2. Okay, so there you got 3 different representations of the function, the equation, the table, the graph. And I'm going to close or minimize this, and I have a previous version, the same representations that I made in Paint, and I just want to draw some arrows here and review with you what we just did. So we started with the equation. The equation gave us our graph over here. All right, so we went this way. Equation gave us the graph. And then the graph, we took these points from the graph, and the points gave us the table right here. Now we know that this is not the only way to make this table. We could also start with the equation and plug in the x values into the equation. Then they're going to give us the y values from the table. We already did 0. Let's try, well, let's put x equals 1. So if you put x equals 1 into the equation, 2 times 1 is 2. 2 minus 4 is negative 2. So when x equals 1, y equals negative 2. So we could also get the table this way, and we could develop all the values of the table from the equation. So what I want you to realize and be noticing here is the connections. We have the connection between the equation, the table, and the graph. And we could even, well, if we could go the other way as well, right? We could put arrowheads on the other end. If I have the table, you could, we could plot the graph. Okay, put an arrowhead here. Not the best looking arrowheads, but I need to get some practice in that, I guess. Then if we have the points, right, then we can find the slope is 2, and then we said the y-intercept is negative 4. That could give us our equation, so we could go the other way with this. So, and then with the table, if we have the table, we could also develop the rule which would give us the equation. So there's a circle. Everything is connected between these 3 different representations. All representations represent the same function we're showing here, and you could start with any one of these. So you could start with the equation and get the graph and the table, or you start with any one of these and you can get the other 2 representations. So there we have it. 3 representations of the linear function. They're all connected: the equation, the table, and the graph.